In this video, we're going to review how to factor trinomials. I just noticed that my crazy, look at my crazy spell check, how it corrected my spelling. Trinomial become polynomials. I think that may be a new term that's discovered under my name. Anyways, different teachers have very many different ways of teaching how to factor trinomials. It doesn't matter what method that you choose. You will never be asked specifically to choose a certain method. You are just asked to factor trinomials. So whether you use the trial and error, use the diamond, the box method, anything, it doesn't really matter. Personally, I strongly prefer the trial and error method because it's the quickest way. Also, it's the simplest way because it doesn't differentiate leading coefficients with 1 or not. If you use the diamond method, for example, that only works when the leading coefficient is 1. So here we go. Let's begin. The way I do it is once you simplify your trinomial, you have a trinomial like this example here, x squared plus 9x plus 18. And all I pay attention to, actually, is my first term with the highest degree x squared, and then the last term. The idea is if I factor the first term, so x times x would equal x squared, and I write it vertically like this. And then I factor 18. There are different ways to factor 18, right? There's 1 and 18, positive and negative, because I could have negative 1 times negative 18 equals positive 18. I can have 2 and 9. I can have 3 and 6. So these are 3 pairs. As you can tell, that the pair most likely that would yield the middle term 9x is this pair, because 3 and 6, if I add them together, I would have 9. So I choose that pair, and I choose, for now, I choose positive 3 times positive 6. You can choose negative 3 times negative 6 as well. We can run that example later, but for now, let's just lay it out here. So again, I have factored my highest term. I have factored my constant term. Now I cross multiply. And when I cross multiply, I have 3 times x, I have 3x. I have x times 6, I have 6x, right? Then I add them together, I end up having 9x. Now look, in other words, I just made sure that my final conclusion here is exactly my middle term. And now the factors are right in front of my eyes, right here. So the answer to this question is x squared plus 9x plus 18 can be factored into x plus 3 times x plus 6. Now let's verify it. If I have to distribute this using FOIL, so x times x, first term, x squared. X times 6, outside term is 6x. Inside term, 3 times x is 3x. And then last term, 3 times 6 is 18. And if I do combine like terms, I just verified that this is my original problem. Okay, so this is how we factor it. Again, just to summarize, first step, factor the highest term, x squared. Second step, factor the constant term, 18. And then in those pairs of factors, find a pair most likely that will yield the middle term and write it out vertically on the left-hand side here. And then cross multiply, add them. If you have the middle term, your factors are right in front of your eyes. Let's look at another example here. So like I said, factor the first term. X squared can be factored into x times x. 8 actually it's negative 8. Negative 8, I can have positive negative 1 times negative or positive 8. I can have 2, and 4, right? I think that's about it. Now, obviously, the pair that's most likely to yield 7 is between, it's 1 and 8. So I'm going to write 1 and 8 here. Now, I want to make sure that this pair multiply each other would give me negative 8. So because I'm looking for negative 7x as my final answer, I'm going to give the negative sign to my 8, to my big number. Now if I cross multiply, I would have 1 times x is 1x, negative 8 times x is negative 8x. I add the two terms together, I should have negative 7x together. So in this case, I do have my middle term answer right here. So my answers of my factors are right in front of my eyes. I can draw the conclusion that x squared minus 7x minus 8 equals x plus 1 times x minus 8. Okay? Now you may say, what if I didn't choose 1, 8? I'll choose the 2, 4. So I could factor the first term, x squared, into x times x, and I'll choose 2, 4, and maybe I'll give the negative sign to negative 4 so that 2 times negative 4 is negative 8. Now if I cross multiply, look at my answer. Negative 2 times x is 2x. Negative 4 times x is negative 4x. I add them together. I don't have my middle term. I don't have negative 7x. Instead, I have negative 2x. And that's how I know 2 and 4 is not the pair for this factoring exercise. Okay? Leading coefficient is not 1 now. It's still the same thing. Again, we factor the first term. 2x squared can be factored into 2x times x. 6, in this one I have 1, 6, I have 2 and 3, right? So I'm going to do this way. Look here, I'm going to do positive 2, positive 3. So 2 times 3, I have 6. Now if I cross multiply, 2 times x, I have 2x. 2x times 3, I have 6x. I add them together, I have 8x. I'm sorry. I have 8x. I don't have 7x. This is incorrect. So this is no. I have to try it again. Maybe, what's the other pair? We said 6 can be factored into either 2 and 3 or 1 and 6. Maybe I'll try 1 and 6, but it's pretty obvious. 1 and 6, maybe I'll do 1 here and 6 here, right? And I cross multiply that way. I have 6x plus 2x. I end up having 8x. Again, it still doesn't help me, but I ran out of factor pairs, right? So what do I do now? Now I want you to pay attention to this one. Maybe if I switch their position, look here, 2x times x, I have 2x squared, my first term. Rather than putting 2 and 3, putting 2 on top, I'm going to put 3 on top, 2 at the bottom. 2 times 3 would give me 6. So I now cross multiply, and I should have 3 times x is 3x. 2 times 2x is 4x. I add them together, I have 7x. Now I do have my middle term right there, my x term right there. So therefore, my factors are right in front of my eyes. My factors are 2x plus 3 times x plus 2. Okay? So again, the method is exactly the same. Factor the highest term, factor the constant. Write them vertically, cross multiply. Hopefully, when you add them together, you have your x term right in the middle. If not, change to another pair of factors. or rearrange the order of one set of factors, like what we did with 2 and 3. Okay, I hope this is helpful. Here is a special case. There are two ways of doing this problem. So let's look at the first way. Notice that I have no middle term, right? My x term is not there. So what I can do is I can do 0 times x. That would give me a 0 and still makes my original function exactly the same. And from there I can just do my normal factoring of trinomials. I factor the first term, 4x times 4x gives me 16x, and I factor my last term, is negative 25, so I'm going to do 5 times negative 5. That gives me negative 25. And if I cross multiply, I should have 4x times 5 is 20x, and then negative 5 times 4x is negative 20x, and guess what? I have 0x. It matches my middle term. My factors are right here in front of my eyes. Don't forget the positive sign in front of the first 5. It's 4x plus 5 times 4x minus 5. Okay? Second way of doing it is that if you remember this difference of squares formula, a squared minus b squared equals a plus b times a minus b. If you remember that, and we'll explain why that's a good function to remember later. If you remember that, you can simply rewrite the original problem into a squared minus b squared. 16x squared is 4x. Be careful, the whole thing in parentheses, squared. Minus 25, 25 can be rewritten into 5 squared. Now I've got my a in here, my b is here, right? So I should have my a plus b, so it's 4x plus 5 times a minus b, 4x minus 5, which is exactly the same answer here. Okay? Now, next, I want to make sure that you understand what is difference of squares and why is it that this formula always works. So imagine that you have a square. This is a square. Let's say the side is 4. And then you have a bigger square. Well, let's say this is one of these beautiful swimming pools in one of these fancy 5-star resorts in some incredible places. Let's say in Bali, Indonesia, and Southeast Asia, with beautiful palm trees, gorgeous white sand, and now it's a swimming pool within a bigger swimming pool and with a square island, and let's say imagine that, and the inside of the swimming pool is 4, whatever the unit is, and the outside square swimming pool has a, I guess, let's say let's call this 10. It's not exactly drawn to scale. Okay, and now if I'm a contractor, I'm hired to lay some marble stones in between these two squares. So I want to know the area, the whole area in this shaded red places. Okay? So notice if I have to calculate the outside swimming pool, I have to, if I have to calculate the larger area, it's simply 10 times 10, right? That will give me 100. That's the area for the first one. And the area for the, let's call it AL, area for the larger pool. The area for the smaller pool is 4 times 4. Is 16. So therefore, my difference of the two squares, the larger area minus the smaller area, is 100 minus 16, and I should have 84. Okay, so that's a scenario. Now, let's use this formula here and plug in these numbers. So I have 10 plus 4 times 10 minus 4. And that's 10 plus 4 is 14. 10 minus 4 is 6. I multiply them out. I have exactly the same number. See that? But this explanation with, this formula is called difference of squares is precisely because of this whole shaded area where it equals the larger square minus the smaller square. Okay? And in fact, you can prove it. I'm not going to do it here. If we call the outside length A, the inside length B, and you can actually prove this difference of square theory. Okay, thank you guys.